Okay, class, in this video we work the example on page 15 of your note packet, and you're given at the top of the page, suppose E of n equal to 5,000 plus 1,000 times n, and G of n, which is equal to 800 times n plus 12,000, give the total cost of operating an electrical versus a gas heating cooling system in a home for n years. In part A, you're asked, find the cost of heating a home using electricity for 8 years. So to calculate that cost using electricity for 8 years, we put in 8 in for n in E of n, and on the right hand side we have 5,000 plus 1,000 times 8, and when we do the arithmetic we get the cost is $13,000. In B, you have to find the cost of heating a home using gas for 8 years. So to find that cost, we put in 8 in for n in G of n, and we have 800 times 8 plus 12,000. And when you do the multiplication and the addition, you get the total cost is $18,400. So for just an 8-year period, right, it certainly appears electricity is cheaper than gas in heating and cooling a home. In part C, you're asked, what is the y-intercept in the electricity function? Explain what the value of the y-intercept means in the context of the given situation. Well, here is the electricity function, and the y-intercept is a constant term, and the constant term is 5,000. So the y-intercept in C is equal to 5,000, and it represents the initial cost, or what is called the fixed cost in accounting, of operating an electrical heating and cooling system. You have to pay that $5,000 regardless for how long you have the heating and cooling system. Similarly, in D, you're asked, what is the y-intercept in the gas function? Explain what the value of the y-intercept means in the context of the given situation. Well, in the gas function, right, the constant term is 12,000, and so that's the y-intercept, right? The y-intercept is a constant term, 12,000, and it represents the initial or fixed cost of operating a gas heating cooling system. You have to pay that $12,000 regardless of the number of years you have the heating cooling system. In E, you're asked, what is the slope in the electricity function? Explain what the value of the slope means in the context of the problem. Well, the slope, right, is the number in front of the independent variable n, and that is 1,000. So the slope in E, right, in part E, right, the slope is equal to 1,000, and it means, in words, for each additional year of heating cooling with electricity, we have to the total cost increases by $1,000. So every year, right, the total cost of heating and cooling with electricity goes up by $1,000. Okay. In F, you're asked, what is the slope in the gas function? Explain what the value of the slope means in the context of the given situation. Well, in F, the slope in the gas function up here is the number in front of the n, which is 800. And so in F, the slope of 800 means for each additional year of heating cooling with gas, the total cost increases by $800. Okay? In G, you're asked, determine how many years it will take before $42,000 has been spent on heating and cooling a home that uses electricity. So to find the number of years, okay, where it'll cost $42,000 total, we put in 42,000 on the left-hand side in the electricity function, and then solve for n. So that's what we did down here. We put in 42,000 on the left-hand side, and now we solve for n, and when we solve for n, we get n is equal to 37 years. So you have to heat and cool with electricity for 37 years for the total cost to be $42,000. And similarly in H, you're asked how many years will it take before $42,000 has been spent on heating and cooling a home that uses gas. So similarly with the gas function, right, we replace G of N with 42,000 and then solve for N. And so that's what we did down here. Put 42,000 on the left hand side, and when we solve for N, we get N is equal to 37.5 years. So you got to heat with gas for 37.5 years before the total cost is $42,000.